Have you ever considered your brain a magnetic entity? If you haven't considered it yet, you definitely need to consider it today. Only then you will truly understand what MRI is all about. If we decode it character by character, you may end up with the phrase magnetic resonance imaging, which literally translates to imaging through magnetic resonance. It might be difficult to comprehend it right now, but within the next few minutes, your understanding will be drastically changed. To truly grasp MRI, let's first appreciate the science inherent in our body. When we look at our bodies, it's a well-organized entity with precise levels of organization. We are such a coordinated marvel of the natural world. If we look at ourselves in the mirror, we are humans. But what if zoom in a bit and view ourselves from the perspective of science? What are we composed of? You will be surprised to know that more than 50% of your body consists of water. Things get even more interesting when you get to know that different types of tissues have different percentages of water within them. Our brains and hearts are composed of 73% water, while our lungs contain about 83% water. Surprisingly, our skin isn't far behind, with 64% water content. Even our muscles and kidneys are quite watery, comprising 79% of water. And here's an interesting tidbit, even our bones, which we might not expect, have 31% water content. It's amazing how essential water is to the makeup of our bodies, isn't it? But this is not just about the significance of water within our body tissues, but rather the whole concept of MRI is based on the amount of water in certain parts of the body. But how? Let's get into the detailed aspects. Can you name the simplest, tiniest element? The answer is hydrogen, which is the simplest known atomic particle with just one proton and one electron. But the simplest element holds the secret to some of the most complex procedures, like the MRI. So, a water molecule is made up of 2 hydrogen atoms and 1 oxygen atom. Picture it like a little triangle. The oxygen atom sits in the middle, and the hydrogen atoms are attached to either side. The presence of a single unpaired electron transforms hydrogen atoms into tiny magnets. How about exposing those tiny magnets within your body to an external magnetic field? Well, the replication of this idea needs a scientific mind. And who was the person who invented such an amazing technology? Do you know the name? Well, even if you don't, let us introduce you to the visionary scientist, Raymond Damadian, who invented the MRI technology back in 1972. Now that you have got the basic information about MRI technology, it's time to get into the details of the procedure. Forget about the tiny magnets that revolve within our bodies. Let's talk about the mighty magnet that can penetrate your skin and even your brain cells. Doesn't it sound like something out of a sci-fi movie? Believe it or not, the super magnet within the MRI scanner steals the spotlight in the world of medical diagnostics. Clinical MRI scanners typically operate at 1.5 or 3 Tesla, and magnetic power in Tesla already speaks for its might. Just to make things even clearer, let's draw a comparison. Some of the most powerful household equipment like refrigerators may have a magnetic power in the range of microtesla. You already know that microtesla is a much smaller unit of measurement. In fact, it's 1 million times smaller than a single Tesla. Now you might be able to get a little idea of the power of MRI magnets. But that's not it yet. Have you ever seen a compass needle? It aligns itself under the influence of the Earth's magnetic field. Now imagine a magnet that's 60,000 times more powerful than the magnetic force of the Earth. So, when your body is exposed to such a powerful magnet, how it's supposed to respond? Well, the tiny hydrogen magnets align themselves with the external magnetic field. This alignment of hydrogen protons just set the stage for something even more fascinating. As these protons align themselves within the powerful magnetic field, they don't simply stay static. Instead, they keep on spinning with a specific frequency. It's that specific frequency that's needed for the execution of resonance. Once your internal magnets have aligned themselves according to the external magnetic field, now comes the time to destroy their alignment. Remember the concept of resonance? For those who don't know what resonance is all about, we will just touch the concept for you. Resonance occurs when the internal frequency of any vibrating body becomes equal to the external frequency. It's the moment when both the interacting frequencies are at the same level, causing the maximum absorption of energy. Maximum energy absorption means an excited state of the particles. Do you know that you are actually using resonance to heat your food up? Just click the link in the top right corner to find out more about resonance in your daily lives. Now, let's get back to the hydrogens that are perfectly aligned and spinning with a specific frequency. For resonance to take place, the external radio frequency pulse is calibrated to match the frequency of spinning protons. When hydrogens encounter these pulses, they absorb the energy and become excited. RF pulses are short-lived. Once all the protons are excited, the RF signal is discontinued. Now, on to the cool part called de-excitation. The protons, hyped up on energy, need to calm down. They are not stable in their excited states and definitely have to fall to their stable energy states. In doing so, they have to lose all the extra energy they have gained during the excitation process. Now comes the final phase of MRI. All of the initial steps were initiated from the outside of a body, and now comes the time when the bodily proton magnets have answered the call. Each excited hydrogen gives off a certain amount of energy while it gains stability once again. The de-excitation energy is then captured by MRI scanners. The greater the number of protons, the stronger will be the signal. As we have already told you, the water content in different tissues is different. So, the received signals are replicated to form an image of body tissues. The more water content refers to the brighter spots in an MRI scan. Just remember that MRI is just a part of diagnosis and not a treatment itself. Now that you have an MRI scan in your hand, the physician will decode the scan for you and plan the treatment accordingly. With that, the physics part of the procedure ends, and the biological sciences take charge. Technically, when the physics part of the procedure is over, it's time to wrap up this video. We have just the physics of MRI that allows us to get into the intricate web of our mind's network, unlocking the secrets of our mental well-being. Thank you for joining us on this exploration with Physics Daily. If you have found this video helpful, don't forget to subscribe, hit that like button, and dive into our next episode where we continue to make physics a thrilling adventure. Until next time, keep exploring the physics that shapes our everyday existence.